So my talk will focus mostly around data management and resilience, particularly around the management of environmental data. So I will do this through highlighting best practices, but from the point of view of what we do as SAEON as well. Um, Just to provide some context, I'll start by introducing the organization I work for, just to give a perspective, and then move on to the best practices and finish off with implementation examples. So I'm from the South African Environmental Observation Network, as mentioned. So we were established in 2002 within the National Research Foundation with a vision to provide environmental research platforms for a sustainable society. And in that regard, we enable long-term um, global change research through the provision of data platforms, primarily located within strategic sites throughout the country and offshore. So we currently operate, we have 7 nodes, with 4 focused on terrestrial sciences. So these are typically inland. And then we've got the 2 marine nodes, one focused on coastal research and another one focused on offshore. And then we've got a dedicated data node. So this presentation will roughly focus on the work that's done by the data node. But we also host 3 research infrastructures that are part of the South African Research Infrastructure Roadmap. So in that regard, we have the expanded freshwater and terrestrial environmental observation network that works alongside our terrestrial nodes. And then we've got the shallow marine and coastal research infrastructure that's integrated with our coastal node. And then we've got the South African polar research infrastructure that's integrated with our offshore node. As you can see with the map, this shows the strategic sites where SAEON operates across the biomes in South Africa. But we also have operations offshore, as mentioned. So our observations go all the way to Antarctica and include Prince Edward Islands. But with that in mind, we operate in a landscape that produces a lot of heterogeneous data from multiple science disciplines. And these data have to be managed within the same organization. But there is an added layer to it where we find that stakeholders, particularly at a local level, need open data, but in decision-ready format. So the development of decision support tools is also essential to respond to global change. And with this complexity, it is very difficult to implement a universal solution for data management. So what we find is that different tools and systems are often required to cater for different stakeholders. So what do the fragmentation challenges look like in environmental research infrastructures? So you've got different data acquisition activities across a wide range of disciplines, and leading to heterogeneous data, as mentioned. This actually limits the opportunities to adopt standards and provide fit for purpose infrastructure due to the level of fragmentation. And especially if you consider what other institutions are doing, not just us. And the siloed approach leads to data not being properly managed. What we find, especially when it comes to data sharing with other institutions, is data policy constraints also do limit the sharing and reuse of data. So in terms of systems design, we've got to take that into mind. So as an environmental organization, we typically primarily deal with in situ data, really. And I often say we are faced with big data challenges from small data sets because the nature of in situ data is that you don't have very large data sets themselves, but you've got lots of small to medium-sized data sets that are very heterogeneous. So, in the context of big data, you often have big data described as one that comes through from large scale projects, often produced by large corporations. And it's often easier to standardize, but it does require high performance computing or large volumes of storage. Uh, and then in our context, what we typically deal with is a concept called long tail data. So, long tail data means large amounts of data coming from very heterogeneous sources. These are often not demanding on computing per se, but because they exist in greater varieties and larger quantities, they are often poorly curated due to lack of standardization, if curation can be applied at all. And then in situ data producers are often faced with this problem of trying to harmonize data sets from different data streams. But there is an added layer as well, especially when you start looking at long-term data sets, where some historic data may exist somewhere, but it was never published in the past. So in the context of SAEON, we find that some of our data actually dates back to the 1930s that was still trying to curate. So without actually properly managing these over time, they do get lost. So data management principles and federated data systems do offer a promising approach to address this challenge. And I will touch on this later on in the slides. So what does trust look like in this fragmented data ecosystem? So it's important to then separate the data sets from the infrastructure, because in terms of data, you can standardize with other institutions, you can standardize within communities, but infrastructure is mostly implemented at the organizational level. So you have two best practice concepts that run in parallel. So one is fair data. There was some mention of it in the first presentation. So this really facilitates the data sharing and reuse and focuses on data and metadata standards as well as data licenses, which I'll touch on. But there's also the infrastructure component that looks at how can we improve resilience, and then focuses on the organization itself and the processes involved in data governance. So although these guidelines do exist, we find that poor collaboration between the researchers and data stewards is often an impediment to implementation. So from the foundation layer, one has to focus on what are the infrastructure considerations. And I would say from an infrastructure view or data and data management view, data preservation is actually the most important layer of information management, regardless of what other services are provided. If you cannot guarantee data preservation, everything else becomes almost irrelevant. So infrastructure needs to be provisioned to guarantee continuity of access. In our context, we've even looked at what happens to our data should our organization no longer exist at some point in future. So strategic partnerships come into play with regards to that. And then it must be able to withstand risks as well imposed by lack of funding, natural disasters. So in the context of data centers, a natural disaster might destroy one. So what we look at is disaster recovery as well, and then available human capacity to support the infrastructure. But increasingly speaking, in the global context of data sharing, geopolitical risks are often a concern. So when accessing data and ensuring its long-term reproducibility, one has to keep that in mind as well. And managing increasing volumes of data in the long term is also a challenge because innovation is usually project driven with limited funding resources. So trying to optimize how we manage data across projects is also important for the long-term sustainability because projects typically end, and if a system is no longer supported because of lack of funding, that data might be lost. So we've got to optimize where we can. And then lastly, access control and cybersecurity. I also like to focus on the legal and ethical considerations when I present these issues. So what we've often found is that there's a concept of, oh, well, there's talk of promoting open data sharing or open data policies, but the role of licenses is usually underemphasized in promoting equitable data sharing. So licenses really do facilitate the proper mechanism for facilitating and reusing data. So the difference between a license and a data policy is that a policy is great, but it's not machine actionable because it's implemented at an organizational level, whereas a license can be read by a data system and processed. And it does provide users um, with some level of understanding of how data should be used and reused or applied. So data users need to understand their legal rights and obligations as well when accessing data. While data may be described as open in a policy, it's sometimes insufficient because it doesn't provide legal clarity. But to promote proper data sharing, open licenses should be used as much as possible, avoiding unnecessary restrictions on non-sensitive data. There are cases where data may be sensitive and restrictions can be used in those. But good examples would typically be your Creative Commons, Open Data Commons licensing, and there are software licenses as well that can be used. And really, the lifting of restrictions when it comes to licensing, it makes it easier to aggregate data sets because when you're creating data products or decision support tools, you might be looking at data sets from different organizations. So lifting restrictions makes it easier to aggregate because when it comes to this level of aggregation, say I'm developing a data product that has some restricted data set used as well. The most restrictive license then must be used to disseminate that product. So lifting restrictions where it's not necessary, it's always good practice. So in our context, what we found is that because we support a lot of data systems and a lot of projects, we have found that what really unites these systems is actually metadata services. So we've designed our infrastructure to cater to 5 use cases, or well, 5 perspectives around data access, focusing on authentication services and access control for sensitive data, data preservation for the long term, data publication and making it available, vocabulary services to harmonize the data within the infrastructure, and then interoperability to link multiple systems. In this way, what we find is is that we're then able to support multiple data archival systems. So in our context, this includes core SAEON infrastructure or archives like our observations database, our data repository, but we also do this on behalf of stakeholders as well as these examples I've captured here. So for the DFFE, for example, we co-developed the Marine Information Management System and the National Climate Change Response Database. And we also have data access protocol servers to host model outputs because some of our researchers do actually do some climate related modeling. Um, and then when it comes to realizing the use case or publication side of these things, these can then be disseminated vi- via different data portals or systems. So we've got the core SAEON data portal, a marine information management system that we co-develop with the DFFE. And we like to issue digital object identifiers as well for all of our data so that it can properly be cited in scholarly publications and attributed. But alongside this, what we try to do as well, because we realize that we cannot operate in silos, we try to feed our data into global platforms. So in the context of the Marine Information Management System, it really is accredited with the Ocean Data Information System. And then in our context, we provide data to the Group on Earth observations. And all of this infrastructure is actually certified. So what that means is that there has been an independent audit that has looked at the organizational processes, the data management procedures used, and certified us as trustworthy. So all of this work does require significant investment in human capacity and development as well. What we found is works for us is to focus our work around four teams. So we have an ICT infrastructure management team that manages the data center. It's currently hosted in 3 locations with a disaster recovery site. And then we've got a data curation team that's responsible for the data standardization and publication. And then this includes the data governance and sustainability metrics for the infrastructure. And then we've got a systems development team that focuses on the overall architecture of our platform. And then we've got, lastly, a data science team that builds data products on top of everything that we host. So the conceptualization, design, and development of data products to assist with the interpretation of data and its translation into knowledge. So how do we bring this all together? What we find is in trying to break through silos, we've got to partner up with international networks as well. So locally, our research sites enable detailed long-term research within defined geographic locations. So we're not necessarily a monitoring network in that regard. So our sites are very, we don't have a national footprint. They're otherwise located at strategic locations where we can detect change. Um, and then this is also valuable because it's ground-based observations. I'm actually glad that it was mentioned in the previous talk as well. It's valuable data for calibration of remote sensing products to inform Earth systems models. Where we operate, we try to make sure that our measurements are co-located between the nodes and the research infrastructures try to ensure some level of co-location where possible and enable integration between biodiversity, biogeochemical, and meteorological data. But with the international network, we then are part of something called the International Long-Term Ecological Research. Through this network, we are exposed to other institutions or networks or regional networks doing similar work as SAEON. And currently, locally, we're able to adopt other long-term research sites from different organizations as well into this. We're also a founding member of the Global Ecosystem Research Infrastructure. So it's a partnership between 6 research infrastructures in the world. There's NEON in the US, which is the National Ecological Observation Network. There's ELTA, which operates in Europe, the whole of Europe. It's the European Long-Term Ecological Research Infrastructure. And then there's ICOS, also operates in Europe. It's the Integrated Carbon Observatory Observation System. And then there's a Terrestrial Ecosystem Research Network in Australia and the Chinese Ecological Research Network as well. And through these collaborations, we do try to standardize some of the work that we do. And how does implementation and scaling up look like in practice? So using the group on Earth observations as an example, locally, you might look at us as a contributor where locally we focus on issues of resource mobilization, data policy considerations, and what standards do we want to adopt. But regionally, this then feeds into some sort of a facilitation mechanism that can then enhance impact. And then globally, where we contribute in the global context, Geo would be the aggregator where we contribute our data, ensure that we've adopted the recommended standards and tailor them to fit our purpose as well. And our systems are interoperable and strategically aligned as well. So because we host data, what we often find is that local stakeholders need some level of interpretation of that data as well. So on top of the core data system, we manage the South African Risk and Vulnerability Atlas, which is also an open access platform that unites data to provide the visual representation of interconnected problems. So this platform was established in 2008 as part of, under the DSTI as part of the Global Change Grant Challenges. It started off as a hard copy atlas, but has now moved into a digital platform to allow for dynamic updates of data products as time evolves. And through this mechanism, we try to then partner up with other organizations as well to build decision support tools that inform policy work. So, for example, last year we did a national climate risk report for South Africa. So we partnered up with the South African Weather Service to produce this. And it was commissioned by the Presidential Climate Commission and the African Climate Foundation. And we're currently part of an EU consortium on spatial inequality in water, energy, food security in South Africa. So we try to bring in collaborations through this platform that can also help us improve the way we manage and disseminate our data and tools. But we also realize that there is a need to leverage new technologies, and given limited capacity at times, there is an increasing need to partner up with other organizations to tackle some of these challenges. So, in our context, we have an AI partner from industry. So, it's called Cindy. They host the largest community of data scientists. And through this partnership, we try to tackle some of these challenges where SAEON, through its data management capabilities, tries to mobilize data to inform hackathons or challenges, certain challenges, whereas they provision the human capacity, because you're talking about thousands of data scientists looking at the same issue at the same time to try and produce an output. And then through this partnership, it then comes back to us for hosting and dissemination once we have results. And just to close off, so on resilience, based on the things that I've highlighted in my presentation, it requires a wide range of actors, including data producers, researchers, funding agencies, the general public, etc. And then adoption of appropriate frameworks through standards and federated infrastructures to inform to work on interoperable systems rather than and break through the silos. But it also needs the adoption of appropriate licenses that facilitate the reuse of information, and requires collaboration at local, regional, and global levels to develop fit for purpose data products and break through the silos. But the last point that I just want to make again is that data preservation and continuity of access still remain the most important facets of data management. So if you can't do anything when it comes to managing data, at the very least, this is the foundation that you should focus on.